So hi everyone, in this video I am going to talk about the cycle graph. So a cycle graph, or also known as a circular graph, is a graph that is consisted of a single na cycle. In other words, some number of vertices are connected in a closed na chain. And then we can say that the first and the last na vertices are equal. So kung saan siya nagsimula, dun din siya babalik in short. Okay? So a cycle C sub n, where in the n here is the number of vertices, and we also have a restriction that the number of vertices is greater than or equal to 3. Because if we only have 2 vertices, then we cannot form a cycle. So there will be an edge from one vertex to another, but we won't be able to return. Okay? So the restriction is that n is greater than or equal to 3. And it consists of n vertices, v sub 1, v sub 2 to v sub n. And there will be edges from v sub 1 to v sub 2, then v sub 2 to v sub 3, until v sub n minus 1, or the second to the last na vertex, to the last na vertex, and the last na vertex, v sub n, will also be connected to the initial vertex or the first vertex, v sub 1. So let's have here the simplest graph cycle that we have. So it is composed of 3 na vertices. So the n here will be equal to 3, and we will have a cycle graph C sub 3. So there will be a path from v sub 1 to v sub 2, or an edge between v sub 1 to v sub 2, v sub 2 to v sub 3, and v sub 3 to v sub 1. As you can see, it has formed a closed na chain, wherein we started from the first vertex and we ended up in, or we ended the cycle in the last vertex, the first vertex, v sub 1 also. Okay? Now, what if we have C sub 4, or we have a cycle with 4 na vertices? So we are already expecting that if we begin with v sub 1, we are going to end at v sub 1 also. Okay, so there should be an edge between v sub 1 and v sub 2, an edge between v sub 2 and v sub 3, v sub 3 and v sub 4, and v sub 4 to v sub 1. Okay, so these are some more examples of a graph cycle as the number of vertices are increasing. So as you can see, it forms a cycle, right? So if you begin with this vertex, and if you traverse through each na vertex, we will end up at where we started or where we began. Okay? Yeah. So now let's have an example here. So we are having here a graph composing of vertices A, B, C, D, G, E, and then F. Okay, so can you find some cycles in this graph? So is there a cycle between D and G? Well, no, because G is an isolated na vertex, right? It's not connected to any of the other graph. Is there a cycle between C and D? No, because our restriction is that the number of vertices will be greater than or equal to 3. In this case, we only deal with 2 vertices. And if we go from D to C, there is no way for us to go back to C and D. Okay? Now, here is an example of a cycle. So we have B, C, E, F, and then D. And then this is also another cycle. D, F, A, and then B. So it always goes back to where it started. And this is also another example of a cycle. C, F, E, and then C. Or you can go the other way around as long as the first and last vertex are the same. Okay? Yeah. So that's all. Stop.